So today we're going to be building off what we did last week, which was sort of taking data from two sources and merging it together so we can put it on a map. And we're going to actually go download some stuff from the Census Bureau and throw it up on the map, because that's going to be, it's part of the homework this week, and it's also sort of one of the most common things you'll be doing, one of the most common data sources you'll be going to. So this also we're going to also briefly, it's good, we're going to talk about projections. This it wants us to open our catalog first. Up until now, up until recently, we've just been it's just been telling you use this projection, do this. But now we're going to actually look into how do you find projections that you want, and stuff like that. So if we go to the United States, we go to PA counties, go to properties. Or actually just description. So we sort of looked at metadata, I don't know, maybe last week, a couple weeks ago. But you can go in here and find, not now. Let's see. Yeah, I guess it does want us. Again, not something that I end up doing a whole lot, which is why I'm going to struggle to find extra what the book wants me to do. But it's important to know where it is. Let's see, yeah. Oh, yeah, you have to actually add, forget this, I forgot you had to do this. You have to go to Customize, Art Catalog Options, and then go to Metadata. And select this North American profile of ISO. And what that will do is give us a little more information about the sort of spatial references that this shapefile uses. So we can see here it uses a coordinate reference, the GCS North America 1983, and yeah, so as its coordinate system. So that's, if you were to run into an issue, like you projected your map up and it looks really, really bad, or it's it doesn't render or something like that, you can often go and check the metadata and figure out, okay, am I using the correct coordinate system? Again, at this point in time, it's not something you'll run into a whole lot, but if you do run into an issue, you can always refer back to this sort of 5.1 chapter to figure out what coordinate system it's using. But beyond that, it's, like I said, I don't use it all that often, but it's important to know that it's there, that you have the option to go look for it. But pretty much, oh yeah, so, and we'll just move on from that. Go ahead and open 5.2. And this is a map of the world, obviously. And up to this point, we've talked about projections a lot, but we haven't really gone into depth of what the different projections are in ArcMap. We just sort of just say, go here, click this, and it will change the way it looks. So if we, let's look at this. To change, and so, this is, I guess, the first time we're going to explicitly teach you how to use projections, but you guys should be familiar with this by now. You right-click the layer group that you want to change the projection, and you go to Properties and open your projected coordinate systems. And let's see. And they're in these, convenient things, so you can just sort of go find stuff. So one that we're most familiar with, or very familiar with, is the Mercator Projection, which is used for, it was originally designed for navigation. It preserves directional relationships, so you can, if I want to go from New York to London, on this map, it's, northwest by a certain number of degrees, and I could open a compass and boom, get on a ship and follow it. And that was what it was originally designed for. But as we talked about in a lecture a while ago, you can see it really, really distorts stuff on the poles. So like this box is the same as this box, which is the same as this box. So you can see it really, really stretches stuff out. And makes things like Canada, Alaska, Greenland, Antarctica look way, way bigger than they actually are. And so some of the other projections we can use, this hammer ITOF, which is sort of looks more like a globe, does a better job of preserving the sort of, not shape necessarily. It doesn't necessarily, like, if you were to look at these from space, the U.S. is a little squished. So is Australia. Places around the edges the shapes aren't going to be preserved as well, but the size is preserved. So relative size of now Brazil and Mexico, or Brazil and the U.S. Are the sizes are represented better than they would have otherwise. And I think they also, I forget what this other one is. We use the hammer ATOF, and then the Robinson projection, which is sort of a mix between the two. So it doesn't distort shape as much, but it does. But we do distort shape. Shape is better preserved, but then size is again a little wonky. So again, this is something you guys should be familiar with at this point. Just like we've sort of clicked through this multiple times in going through assignments. But this is just the part where we actually officially show you what it is. And then, so obviously this is a map of the U.S. And I think, as I've told some of you, you will see this map. Journalists or something will have put some data on a map, and they won't have projected it, and it will look like this, and should bother you. It does, at least it bothers me. It's like it grates on me a little bit. But again, the U.S. The one that we've been using is, again, we go to continental North America. We've been using this North American Albers Equal Area Conic, which does a good job of sort of preserving size and shape it's a good middle ground. So, but again, this is not, so like this is a good projection for the U.S., but if we were to, say, zoom in on New York, it's not necessarily the best projection for New York, because it's having to take into account California and Florida and South Dakota, right, in how those all relate to each other, not with necessarily how the different boroughs of New York relate to one another. So we can actually go in here and go to Properties, go to the state plane, which we'll do here in a second. I'm sort of getting ahead of myself, but default to this one, and then we just go find New York, And I'm sort of guessing here. So we have Central, East, and Long Island. I think Long Island's probably a good guess here. I'll show you guys how to officially actually go look up which projections to use in a second. But so this, you can see the map tilted a little bit. It didn't actually change shape all that much, but it does. It will sort of, as you get closer and closer and closer into the map, it will show those features in the best projection that we have for them. So. I guess it wants us to. Oh yeah, so we're gonna open a new map, and say we want to add. Let's see. If we go into data, I think is it Allegheny County? Is that what we're using today? Yeah, Allegheny. And we add the sort of shape of Allegheny County with its various I believe these are municipalities within the county. So this is sort of what it looks like, and we could go and sort of click around and try to figure out which one looks the best. But we can actually go to the internet and figure out which plane or which coordinate system to actually use. So, so if we Google state plane coordinates and something like NGS, should get us to this NGS NOAA Gov. The official website is this, and I can throw it up there for you guys. If we, whoops, not sure what I just opened. Oh, that's Adam. I didn't know I had that installed anymore. This is the URL that you would go to figure out the state planes to use, and it's in the book. But again, you can just Google something like state plane coordinates NGS, and it should be the first selection here. And we want to go to find zone, which is down here, and it should take you to this place. And so we're gonna since we're using a county, that's probably going to be where we're going to want to go, and we go down to Pennsylvania, and we're using Allegheny, and we get this is, it just spits back some text at us, and I can put that up on the. So we have PA003 Allegheny County, which is the designation for Allegheny, and then we have our NAD 83 zone is equal to 3702, or the Lambert/Southern zone. So that might not make a whole lot of sense, like on its head, like face, like that doesn't make sense right now to us. But if we pop into ArcMap, we can go to Properties, and so I've already opened the state plane here. So so I'll just sort of go back down here. So again, we're going to pop into projected coordinate systems and find the state planes. And since we saw the NAD 83, we have NAD 83. The 2011 should be the most updated one, and we're going to use feet since that's just sort of what we use. And we're going to scroll down to Pennsylvania. You'll see all these have the states associated with them. And Pennsylvania has a north and a south zone. If we hover over this says Pennsylvania South, FIPS 3702. and north says 3701, so we can go here, and 3702 was the zone that we were looking for. So if you are ever unsure of which projection to use, did that actually take? Yeah, okay. Then you can always go look it up here on NGS's website. But so beyond that, we don't really need to change much. We can I guess it wanted us to add tracks at some point too, so we can do that. So these are now all the tracks within the municipalities of Allegheny County. We can sort of make this so right now everything is in feet, and you can't really see this, but in the bottom right corner, it's giving you coordinates in feet. But like the rest of the world doesn't use feet, so if we want to project this map and get a projection that's still true to the sort of geography of this place, but we want all of our calculations to be in meters versus feet, we can do that. And that's designation is going to be under this UTM folder. And again, there's a whole bunch here, so we can click around and try to find it, or we can actually go to the UTM's website, which is dmap. Okay. UTM. So I'll put this up. It's dmap.co.uk/utmworld.htm. Again, you could probably just Google dmap UTM world, and it's the first result. So we end up with, it has sort of sectioned all of this off in grids, and what we want to do is we want to, let's see, I mean, I guess you could, you could just draw this like 17, it's like 17 and then T17 and draw it like that, but that's, you used to be able to just like punch it in. Yeah, that's... I mean, so this is a rough way that you could figure it out. I mean, knowing that Allegheny County is sort of in this western part of the state, we can sort of look, okay, we can draw 17 up, and we know it's T17. It's a rough way. They've changed the website. It might probably move somewhere. But again, we can go to the, after we've sort of figured that out, we can go under UTM to NAD 1983, and we have 17 north. And it slightly shifts our map a little bit, but we can now go to Properties General, and we can display everything in meters, and that shifts our map a little bit if we wanted to, share our map with. This might, using meters might be something you would want to do if you're using, the International Terrorism Database, since the international measurement system is often based in meters or kilometers. Being at least vaguely familiar with how to switch everything over to meters is, I think, probably worth figuring out. Cool. Alrighty. Any questions so far? This is all, this is something that we've sort of done already, but it's good to sort of come back and look at it. Look at it again. Yeah, and you can sort of go through this process and preload different shape files with projections in Art Catalog. Again, it's not something I do a whole lot, but if you want to look into more of that, it's on page 184. But okay. Okay, on Monday, Dr. Gimple was talking about sort of different, and I think he's talked about this in the past as well, different ways of sort of showing things displaying stuff on maps. I think he talked about different, like vector formats, and that's sort of just a broad way of saying a different way to draw shapes onto our map. And there's a different couple of ways we can do this. The most common one is a shapefile, which is was Esri's development of Esri's in the 90s, and they're prolific. You see them around all over the place. The biggest downside to a shapefile is their size. You can very quickly have shapefiles balloon up to like the size of like 2 gigs, stuff like that. And so if you ever run into that, and the book doesn't really cover this, it's just something I'm throwing out there. If you run into this, one of the best things you can do is take that shapefile and create a geodatabase out of it, because what that does is compresses the file down, makes it way more manageable for, it takes up less room on your hard drive, but it's also easier to share, right? Like it's hard to email a 2 gig file. It's even hard to upload a 2 gig file and share that, right? You can, but it's much easier to say upload a 500 megabyte file and get that to someone, or throw it on a flash drive and give it to someone. But that said, shapefiles are still super useful, and again, you'll see them all over the place. So, and that's the first place that they sort of drop us in when looking at different vector file formats. So if we go, so I'm in Art Catalog right now, and we're just going to sort of look at these different things, and we can see here we have Allegheny County. We have its shapefile. I think we should be able to preview it. Yeah. So this is what it looks like. Obviously, it's unprojected right now, so it looks a little different. But we can sort of click around and look at these different things, and this is sort of what a shapefile looks like here. But if you go and look at a shapefile on your computer, so just like in Explorer here, I can go to Data, and we have, here we go. So this is the same folder here, this Data Files folder right here is this same folder on my screen. And you can see it sort of explodes a shapefile explodes into about 7 different separate files on your computer. So that's just sort of, if you see this when you extract something. So if you download a shapefile, you will often see a lot of this stuff here. And so that's just be aware, like, oh, that's a shapefile, but it just looks different in sort of the Windows, when you're looking at it in Windows versus when you're looking at it in ArcMap. There are some old file formats as well, like you might run into these, especially like in various like online archives, or if someone hasn't made a new map of something in a while, you might run into some old files, and ArcMap can still use those, and so it's just good to be aware of like what they are. So one of those is called a coverage. So if we go to Add Data and we navigate towards Pittsburgh and I think East Liberty, we see these different files, and we can go back to here, Pittsburgh, East Liberty, and we have these different folders here. If we go into Building, we have this like big grouping of different files. So, but if we add one of those in ArcMap, it knows what to do with it. So this is I guess what they call a legacy format. It's just been around for a while. Yeah.
Whenever I add one of those, it just says it can be drawn but not projected. Do you know why that is?
But is it showing on your map?
It shows it. It just says it can't be projected.
That's because it's essentially just reading it as like lines, because that's how they used to not be able to project maps. Like you could just draw it. You could get a computer to draw exactly. It would draw it one way exactly, and that was it. And so you're not going to be able to project a map like this. But you can. You can't project it in this format, right? You can convert it into a shapefile and then project it.
Okay.
So, and that's what we're going to do right now, actually. So, what we can do is just sort of right-click our building thing and go to Export. Oh, wait, hold on. So we. No. Oh, I'm clicking the wrong thing. Go down to, so you right-click Building Polygon, go to Data, and go to Export Data. And it will give you an option to sort of put this into a format that you can play around with more. So sort of choose where you want it to go and choose a name for it. So we're going to call it just Buildings. And I'm putting this in the Chapter 5 folder. Oh. Why am I getting an error?
I get this one.
This worked at home. Okay. So the default is going to be File and Personal Geodatabase feature class. Since we're not we're not saving it into like this. Well, so we're not saving it into this Chapter 5 geodatabase. So we can just click off that and go to shapefile. That way it's its own standalone thing. And click save. And then it should export it as something else. So if we, so now we have the same thing, but now it's a shapefile. So we've updated the format, and now we can do sort of modern things with it. So we could go in here and we could project it if we wanted to. I believe this was Pittsburgh, so. Pennsylvania South, and again, it doesn't really change. It didn't change the way it looks, but if this was a bigger map, say of the U.S., it would be much easier to sort of see that change. I think this is like a couple of blocks in Pittsburgh. Like it's a neighborhood in Pittsburgh called East Liberty. So this is coverage. It's just something to be aware of that it exists. So if we open a new thing, we can also add CAD files. Like if you guys have heard of like AutoCAD or something like that, engineers and architects use it to draw objects, or if you can now draw figures in AutoCAD and 3D print them or whatever, but you can also draw like maps in CAD. This is, again, not as common, I think, as it used to be, but you still might run into CAD files of certain places, and ArcMap can use those. So if we go to, so we're adding data, and I think we go to data and then CMU campus, you'll get these different things. So I mean, there's some shape files in here, but you'll see these DWG, and that is that's just a CAD file. So this is a campus map that someone just drew in AutoCAD, and you can put it up on a map. And just like AutoCAD, you can sort of click stuff on and off. Like you can turn some of these point files off, so we can turn annotation off and stuff like that. And so then we see. So if we turn this polyline feature off, it turns everything off, but we can actually go to properties and go to drawing layers up in the top left, and we can choose what we want to draw. So if we unselect everything, we can only shoot, like this is just the buildings on campus. So again, not something you're going to do a whole lot, but you might run into some CAD stuff depending on sort of the line of work that you're working with GIS in. But it's good to know that it is that it's there. We can also export stuff to CAD. So if you wanted to export a map and open it in CAD and sort of edit it, you can do that too. So this is the 3D Analyst geodatabase. We can sort of put everything in here, and we get this this looking map here. Shouldn't be showing pictures behind. Hold on, I think this has to do with something that's coming up. So restart it. All right, do the same thing. Still, oh, I just can turn this image off. Okay. But we can then take this and let me find. Here we go. Yeah. So if we turn. We can turn everything off so we just have topo here or something like that. We can take this and go to data export. Why is that not a data? Oh, export to CAD. Duh. And you essentially get this thing pop up, and you can export it to a DWG file, and you can open it in AutoCAD. Again, this is basically just to show you this is possible. It's not really going to be within the confines of this class. Like, we're not going to use that option very much, or really at all, past today. But part of this class is just sort of giving you a tour of what the software is capable of doing. So sort of now that we've sort of gotten through that stuff, we're going to go to the sort of bread and butter of what GIS can do, and that's sort of downloading data from the internet, combining it with a shapefile, and then putting that data on a map. That's sort of why we're here. So I think what we're going to do is download the county. I'm going to go ahead really quick. Since I've done this on this computer already, I have all this like extra stuff. I'm just going to just so it's easier. I'm going to have geodatabase here as well. You don't have to do this, it's just sort of getting ready for this part. So essentially, if we go back to the internet, we can go start downloading shapefiles. And we can download shapefiles, we can download data, and put them together. It's sort of essentially what we did last week, but we're going to go download the data instead of having the data given to us. So if we go to like Census, yeah, so you can see I've already searched this. Census 2010 shapefiles. This will get you to where you want to go, and this sort of tiger line shapefiles from the Census Bureau is sort of where you want to be. And right now we're still working with 2010 census. Obviously they update this stuff on a yearly or semi-yearly basis. But for now, we're just going to go back. And once you're here, we can click 2010 and then download, and then it will take you to this looking website here. And what we're going to do, we're going to look at Chicago. So Chicago is in Cook County, and we're going to sort of download some data and sort of put it on the map for Chicago. So we look at year 2010. What we're going to first want to do is download counties and equivalent and click submit. And then, so the first one here is 2000, but we want 2010. So we go down to Illinois. We sort of have all of these here. So it's going to download it into a zip file. You'll see here in the top corner, there's this pink line that says compressed folder tools. If you want to use this in ArcMap, we're going to have to decompress those, all right? Uncompress them. And you can do that by just opening two windows here, and you can just drag the files into. I'm putting them in Chapter 5. You can put them where you want to put them, or you can just go to Extract, and click Extract All, and choose a place that you want to dump the folders. And so, so now we have, again, so this is just a shape file. Again, it exports a bunch of different files, but that's what we want, right? So we have the county. Now we want to get the tracks. So we go to 2010, go to Census Tracks, and we want to select 2000, or 2010, Illinois, and we want to select Cook County. And we're going to do the same thing we did before, which is, take these files and dump them over here. So now we have we can sort of go to our Chapter 5 folder. And we have two shape files. So we have our counties and our tracks. You can't see, so won't let me rearrange this for some reason. But if we hollow it out, we can see up here we have Cook County, where Chicago is. But if we go look at this, so if we're interested in sort of information by tracks, if we open this attribute table, again, this is not very useful information for us. It's just like short of shape stuff. So what we need to do now is go to the census. Oh, actually, it wants us to do one more thing. Scroll down and find water. And download that as well. And that way you can sort of have all the water from Cook County as well. So it sort of looks like this. But again, we still need to go get information. So if we go to Census, the Census Fact Finder, just Google it. You'll get to this website here. And what you want to do is go to Advanced Search, Show Me All, and you'll get to this website. I'm about to sort of go through this pretty quickly, as I always do, but it lays this out in on chapter or page 193, and this is just, you can just go back and sort of follow along. It's pretty simple once you figure out sort of how to work with this site. But what we want to do is select geographies and go to name and click down the side. Where is it? Census tract. And that will sort of filter out everything else. And then we want Cook County. Cook County, Illinois. And so then you'll be met with this. And again, it's hard to read, but you want to select, it's the third option for me. It should be the third option for you as well. All census tracts within Cook County, Illinois. And then click Add. And what that does is now it's populated all the census data it has for the census tracts for 2010. And I think the one it wants us to do is, so you'll see on the side, this is 2015 5-year estimates. So if we want to use the data the book wants us to use, we go to age groups, and it'll be age groups and sex 2010, and just click go, and then we end up with this. And so I'm going to select the SF1 100% data, and click view. Got to do some thinking, and this is sort of what the data in this looks like. So you have these are all I believe these aggregate numbers. There's this for a single. Oh, so this is just for Census Tract 101. This is the data, but it's all. I mean, it's all in here, and so what we can do is just go to download, and this is really important. You want to, when you click download, you want to click use, and it will give you two more options that are merge annotations into a single data file. You can leave this on, but before you import it into ArcMap, you have to delete a line. So this can be useful for figuring out exactly what the codes mean, because it's just going to be a weird code. It's going to be like HC101-B. It's just like, it's essentially nonsense. It's a code name. But if you leave these things clicked, you do sort of have to do some more editing of the file. The book tells you to leave them unclicked. I'm going to tell you to leave them clicked because it's not that hard to do this edit, and it makes sort of figuring out what your data is way easier, because you don't have to dig through code books to figure out what the codes mean. So sort of after you get these files, these are zipped again, so you have to unzip them to a folder here. And if we click the CSV file, this is essentially all the tracked data. So these should look familiar to you. This is GeoID, GeoID2. These are sort of things that we used last week to join data with. But now you can see here, so we have total population, male population, female population, and stuff like this. So if you'd unclicked those two things, you would have to go to a code book to figure out what these numbers meant. And so now that we know what these mean, we can do total pop. We can start renaming stuff. We can total pop, male pop, female pop, and these are sort of the variables that we want to grab. And so we're going to also name this ID and ID2. And now that we've done that, so I did that sort of quick. Now, before we actually open this in ArcMap, we have to get rid of this line, because if you try to import this into ArcMap with this stuff still included, ArcMap will freak out and it won't open the file, or it won't be able to use the data. So once you get the information you need from this this row, you need to go over to here, right-click the 2, and then go to delete, and that will get rid of it for you. And sort of, so while we're here, we don't need any of this data for what we're doing today, so you can just delete it. You don't need this either. So now we have a really nice, simple file. And if we go save it into chapter 5, and we do and it's going to default to a CSV file, but go up and click Excel Workbook. And this is useful because it will help keep the format of our numbers. Because right now, so this is a number. These are numbers, right? This is an Excel file. But if we go in and we look at, so here we have, in our census tract shapefile, if we open the attributes, you'll notice we have our GeoID 10 number here, right? So that's the one that's our tracts, and that's what we're going to want to join on. If we look at what this is, it's actually in string format. So we're going to have to either change that to a number like we did last week using the field calculator, or what I find to be easier instead of going through the sort of field calculator process is we can actually just edit it directly in Excel. It's more intuitive. It's easier, and sort of feel like it just makes more sense than trying to go through ArcMap's attribute table. So what we can do here is, so this is our GeoID 10 ID 10 variable. In this, it's called ID 2. What we can do, you'll notice all of these numbers start with 17031, and that sort of holds through all the way down through the bottom. So each tract. So what we're going to want to do is change these from a number to a string. And the way you do that in Excel is add an apostrophe in front of the number, and Excel will now treat that as a string. So I can just do it with 1 here. And now you'll see it shifts. It's hard to see, I guess, but it's, I can bump up. It bumps it over to the left. And in Excel, if you know anything about Excel, things that are left aligned are like letters, and things that are right aligned are numbers. But instead of having to go through and do that, adding an apostrophe in front of all of them, obviously it's much easier than that. You select the whole row and go up to the top right. You should see Find and Select. If you're in this home tab, go to Find and Select, and then click Replace. And you want to find that 17031 beginning, and you want to replace it with, with apostrophe 17301. And what that will do is it will force, is it just 1703 actually? I forget what. Well, it should be fine with 1703. I think it's upset because I did one of them already. Not entirely sure. This is frustrating, because I literally did this morning. I'm not sure why that worked. The first time, but I don't know. I think maybe I was clicking replace. You need to click replace all, and that should change all of these to a string. And this sort of process is important, and like being able to do this is, I think, really valuable, and it will save you a lot of time. So, and you get to avoid having to use ArcMap's attribute table. So now that we've done that, we should be much easier to get this to work. So I'm actually going to open a new thing, and we are going to create a new file geodatabase by importing all of our shape files here and clicking OK. And so now all of our shape files are sort of in this nice tidy package. And then we can go to import table single and import this brand new census tract file we just made. And we're going to go tract data. Okay. So now in our file geodatabase, we have sort of all of our data here, and we can now add it in. Essentially the same map we just had, but now we're going to have our data. Again, it's important to project just to make the maps look better, and this is going to really change sort of pictures here. So we go to Illinois, and we're going to go Illinois East is what we want to use, and then there we go. We have a sort of better looking map of the sort of Chicago area. And so now essentially we have gotten up to the point that we got to last week, right? So we were given a bunch of data that was not joined, and we've now just gone and got that data, got it prepped, and it's ready for the joining process. So essentially we're just going to right-click tracks, go to join, and we're going to find our GeoID10 variable, and we're going to choose ID2. And now, if we open our attribute table, we go to the end, and we've joined this information. So I mean, this was a census shapefile that we downloaded and census data that in about a half hour, probably quicker than that, 15 minutes, we were able to sort of slap together. And now it's just as easy. We can draw using that data that we had. So if we want to look at sort of do male population over total pop. We can quickly draw a map. So that, caught up. And you can, so I guess at this point we only have about 10 minutes left. Is there a question questions about what we've just done? I know we're flying through it, but it's the sort of nature of what we have to do. Yeah.
How'd you get to that table to table again?
What do you mean?
When you added the data, the Excel file.
How did I get to which part of that?
Get to like the part where you added the table to table part.
So I can show you really quick. So essentially, so once all the data is in here, and you've sort of made it already, you just right-click. So we have...
Not the joining. Like
oh, not the joining.
Adding the Excel file to our...
So I just saved it somewhere, right?
Yeah.
And then what I did is I had this file geodatabase right here, and I just right-clicked, clicked import, and then table, and I went and found it like this.
So you gotta find your saved file in your file viewer.
Yeah. Yeah. So So I just over here in catalog, you can just add it from there. We can. Let's see. Can remove this really quick. You don't necessarily have to do it that way. Like, so say you just saved your file, and you have your. Since essentially like what we just had here. Okay, it's gonna to. So essentially, I've just created the same map or whatever without not using the file geodatabase, just by just clicking add data, and I can do the same thing with the Excel file. So I can just go to click add, and then find my Excel file, which is right here, and click add, and now it has added that to here as well. So we should be able to go to our tracks, click join. GeoID 10, and it's so you can do it outside of the geodatabase. I know that will sometimes cause people to have crashes or errors if you don't do it that way, if you don't do it through the geodatabase. But it's sort of like if you're just slapping a map together, like I don't often put it together using a geodatabase. But like if I share data, if I'm trying to like package all the data and share it with someone, I'll put it in a geodatabase, and then I can send it to them. That way they have all the data ready to go. But did that get to your question?
Yeah.
Yeah. It's just you just add data like you normally do. So, other questions?
Yeah, I thought you had to go through that table thing.
Oh no. Yeah. Cool. The rest of the chapter, it shows you can download, and this is, I think, maybe important for the homework as well. If we go Cook County, Illinois, census tract. Add. So we've just been using like population data, but you can also go and click after you sort of. So I have Cook County census tracts like ready to go. You can go over to topics and filter by different things. So you can filter by people and then education, and then you could do educational attainment, and that will give you access to different data. So this is how the book tells you to get at this point. Go to get the educational attainment. So that's how you would do that. And I think for the homework, it asks you to get heating and fuel for all counties in the U.S. So the way we would do that is, so we want to select our geography. So what do we want to look at? We want county. And so it will say all counties within the U.S. We can click that and then click add. So now we've sort of filtered down. We're only looking at county data for the U.S. We go over to topics and then housing. And I think physical characteristics. Oh yeah, physical characteristics. and then heating fuel. And that will filter down to this. And so then it wants you to add things like, yeah, so the B25040, house heating fuel, and then you just would click download, right? Again, it will kick you to this stuff, and I've downloaded the file. For now, I'm just gonna drag it onto my desktop. And so now we get stuff like this. So we have estimate total, we have these margin of error stuff. So you can, for these margin of error things, you can get rid of, so we're not gonna use them. So here we go. We have gas, bottled tank, LP gas, electricity, etc. So it will ask you, I think it wants you to get utility gas, tank LP, electricity, oil, coal, wood, solar, other, no fuel. So you can just go through and sort of figure out which ones you need here. So here's oil, and getting rid of these margin of error things. Here we go. Yeah, so essentially all of these, it wants you to use all the different ones, and so then again you would go through, change this to total, gas, bottle, electricity, oil, coal, wood, solar, other, none. And that way, so after you change it to something, it doesn't matter what you change it to, change it to something that you know what it is, right? And then you can again go ahead and get rid of that second line because you're going to need to do that. And now you run into an issue where all of these are, you can't do that search and replace thing, right? Because they don't all start with the same number. But what you can do is select the top number, go down to the bottom number, then right-click it, go to Format Cells, and then go to Text. So it'll say Category, go to Text, boom, and it'll pop it over to the left. And that way you don't have to do the search and replace thing. And then you could just save this, and I'm going to save it on my desktop and like fuel data, change it to an Excel file. And that's how, and then you would have your data ready to go for the homework. So I'll upload this, so if you want to go back and just do that, follow along, like that's great. That's what it's there for, just sort of help you like walk through the steps. But cool. And then the rest of the book is not that important. It's sort of like downloading some maps from different sources. But again, the census stuff is bread and butter, especially for this course. But yeah.
So since you said something that's not important, should there be things that we skip in the tutorial?
Yeah. So I need to go and update the sort of outline.
What would you say we should skip?
Let's see. We'll say skip. So do everything. So I would say, if you're just going to go back and do this again at home for yourself, I would start at 5.6 and do 5.6, 5.7, 5.8. And I'll update that. I'll update that on that. Has everyone seen this thing I sent out? It's the sort of an outline that sort of just talks about the tutorials that need to get done, and I can go ahead and edit it really quick. Only the, okay. I'll have to log in and do this. But yeah, so 5.6, 5.7, 5.8 should be solid. Like that's all you, that's really like, that's the core of like what you need to know for this class. And the core of really what you would need to use GIS out in the world. Otherwise, everything else is sort of specialty use. Like if you're going to go, but if is anyone in wildlife sciences or anything like that? Yes, maybe it's something me and you could talk about if you wanted to like download topographical maps or natural resources maps or stuff like that. You can still get some of that stuff from the census, but there are other places to go look for that, even better places that even the book doesn't go over. So, but cool. Well, cool. Thank you guys. And I know some of you, I've said stick around. At this point, if anyone's still having like technical issues and you haven't reached out to me, like let me know so that we can like get cranking and like get you up and running. I have come up with some better ways, especially for Mac users, to run the stuff. So I know I'm working with Ashley and I think a couple other people today to get theirs up and running. So if you need anything, reach out to me. I can come in, essentially all day on Friday and sort of sit with you and like get it ready, help you catch up. That way we're sort of rolling in. I think the test is not next week, but the week after. That way it gives you sort of 2 week period to sort of get you caught up and then ready for that. So thank you guys.